Okay. All right, we're all set now. First thing that I want to talk about is where we are on the schedule and what's going to happen here. All right, so I hope you all had a good Mardi Gras holiday. We didn't meet last week. Okay. Probably most come down here. So now we're on February 16th, and the title of this I probably should have updated that. We are going to cover objects and external modules, but really the focus of today is going to be a continued discussion on this entity here, dictionaries. This entity here, dictionaries, and we're going to talk about reading files. And we are going to talk about objects and external modules. Basically, though, as a springboard for next week's discussion, where we're going to start actually using GIS in our Python. And so this marks the last week that we're really going to be following this book that I've had you utilize. From now on, the book will be like a reference because you're still going to have to write things in Python, but we'll be doing more GIS stuff, and even the labs today will have some GIS element. I'll have a GIS element, but we won't specifically start using GIS until next week. So that's the 20 to 23rd. Now, as we continue in here, I knew that there was probably going to be a week where I would be traveling, and it looks like that it might either, I haven't actually hammered it down now, but it looks like it might be the 1st or the 8th. And so if that's the case, depending on what I think we should do, we'll either not meet or I'll pre-record a lecture, and you can be kind of like it's an online course. You can ask me questions and stuff, but I won't be here. So I don't have that date nailed down, but look for that, and I'll upload this. That might be either the 1st or the 8th. So this is kind of exciting. Oh, go ahead. I'm not going to AAG. Are you going to AAG? What about you? When is AAG? The 29th and the 2nd of April? Okay, so you might miss the 29th. Okay. Well, even if that is, what's that, San Francisco? Yeah. Yeah, good to visit San Francisco, that's for sure. So, so yeah, but that's a week I'll probably be here, so I'll probably still hold class on that day. All right. Yeah. So anyway, what I was about to say was this marks the end of the strictly learning Python today. Okay. So like I said, we're going to follow. I forgot the chapter numbers in the book, but I do believe that's pointed out. If you look at week 4 here. All right. So today we're gonna finish talking about sequences, dictionaries. We're gonna talk about modules. We're gonna talk about classes and objects. And again, we're really gonna limit our discussion to a very cursory introduction to this concept, because we're not gonna really write our own classes or objects for this course. We will do one example in the lab today. Writing classes and objects are more often activities that computer scientists do, and we as consumers can write our own classes. Consumers of GIS technology can write our own classes and objects. More often, we're looking to like glue together things that other people have already created, and And then our unique contribution is some sort of geospatial analysis as geospatial scientists. All right, so and then we're gonna discuss reading and writing files. That's going to be one of the newer big things that we're going to discuss today. We're going to discuss a little bit more in the debugging realm down here. And then finally, I'm going to introduce, have a discussion on external modules and introduce some of the ones that we're going to utilize for this course. Particularly the one we'll be using for the next few weeks will be ArcPy, which is basically just running ArcGIS through Python rather than running it through the command line. So we have the opportunity to do things, automate things, do things over and over, quicker and easier, and then, or more quickly, I don't know which the proper grammar term in that regard. And then also we have a little bit of an opportunity to kind of manipulate the points, lines, and polygons in ways that we couldn't. So like do special analysis. And obviously that would be a big box to open, special analysis, what does that mean? But we'll provide a few examples and practice a few examples of doing that. And then these are some other external modules that I'll bring up, and I'll do that more when we get to that point in the course. Okay, so let's start off with, let me just make sure that I'm continuing to record. It looks good. So let's start out by opening up IDLE that we've been working with. And I tried to make this a little bit bigger. Hopefully that works. The trade-off is not as much fits on the page. So anyway, let me know if you think I should go back to the smaller one. Probably not a consensus that we could get anyway, but with 4, maybe it's more likely than if it was a larger class. So I'm going to just start off in the interactive window rather than creating a script, just to show the notation for a dictionary. So I can create a new dictionary. I'm going to just call it my dict. I'll just call it MYD for short. So I've got my dictionary, and the notation to create your own new dictionary is a squiggly bracket, indicates that you're going to start up a dictionary. And a dictionary, very simply stated, and it is a pretty simple concept, is a set of key value pairs. So there are keys and there are values. The keys in a dictionary are what are used to reference the values. So an example here that I could set up is I could have the names of buildings. So the Walker Science Center is the name of the building that we're in, and I could have the number of floors as a value, okay? And I could have Johnson Science Tower, and I could have the value be the number of floors, which I don't know, so I'm going to say 12. Okay. And then we have the old Kelly Hall where we used to be in geography. I'm not sure if there's an EY or not. I don't think there is. Kelly. Yep. So Kelly Hall has a single story. So little single story building behind a gas station. So my dictionary has 3 items in it. It has Walker, Johnson, and Kelly, and the values are 2, 12, and 1. I do. Thank you for pointing that out. So the key value pairs are separated by commas, and so now it's correct syntax. Thanks.
The key is what, and the value is the number.
Right. Now, the keys can only be simple data types. They can only be strings or numbers, and I'm pretty sure they can only be integers, not floating point numbers. So the key is first, just like you said, it's key and then value. The value is actually unrestricted. So the value portion, where I have 2, 12, and 1 in my dictionary, could be anything. The value could be a string, it could be a floating point number, it could be an integer, it could also be a list or a tuple, and ultimately it could actually be another dictionary. Or once we talk about objects, it could be an object. It could be a function as well. And those would be, a function would be a fairly obscure thing to store in a dictionary. We probably don't have too much application for that in this course. Okay, but the key has to be one of those things, the string or an integer, and the value can be any valid Python value. Here, they're all integers. And actually in Python, they also don't have to be the same. So Walker could contain a list as its value. Johnson could simply have a number. Okay. However, in practice, oftentimes the values are all of the same data type, because it's kind of like we're storing a set of information. Okay. So another way to look at this might be a table where the value Walker was one line in the table, and then the value would be 2 or 12 or 1. Right. So when I hit enter here, now if I print my D, it'll be reformatted, but I'll get that same text that I just entered. But now it's a dictionary. If I ask it for its type, it'll tell me it's a dictionary rather than just a string or something. Okay.
Okay, so I put it. So numerically, what's it doing? Does it flip-flop Johnson and Kelly?
It did. Okay, so there is actually not a reliable way to predict the order that items will be stored in a dictionary. Okay, so that's a great question. However, usually it doesn't matter. We're trying to access these items by their key. Anybody have a guess at the syntax for accessing something in my dictionary? So if I wanted to print just something in there, I could say MyD. It's actually like, okay, now if it was an array, or a list, sorry, if it was a list, you'd do something like that, right? And I'd say, okay, I want that would be which item, and if this was a list, which item? The first item, exactly, okay? Now, since this is a dictionary, the way that I ask for an item is that I actually provide the key. So now, what do you think is going to happen when I press enter? Right, it's going to return the value, it's going to print the value of MyD Walker. And I print that. And remember, I know I know we've said this before, but Python doesn't care whether you use single quotes or double quotes. Okay? So those both denote a string. Now, Python, though, is case sensitive. Okay, so you cannot do this. Like if I say Walker here, all lowercase, I'm going to get an error. Let's see what the error says. It says key error, Walker. The way that you can interpret what it's trying to say is to understand that there's an error with that key, and it's because that key doesn't exist. Okay. it can't find it. You can ask you can ask if it is in, just like the other one. So you could say print Walker in MyD, and it would say true. Now I'm getting to the bottom here. So that is a valid Boolean statement. Walker in MyD. In other words, if you wanted to find out if a certain key exists in a dictionary, you can do that. Okay. All right. It's fairly easy to add a new item into a dictionary. Let's see if I can think of another. I'm gonna have to make this smaller to fit on the page. There we go. It's fairly easy to add another item into a dictionary. I can say MYD for my dictionary and put in another build. So let's put in Lucas. So Lucas building here is the administration building, and I think it only has 2 floors. Yeah, the one with the dome on it. But yeah, I've been in there a few times. Never been in there? Yeah. I haven't been in there too often. We used to, they don't make us do this anymore, but it used to be that when we went to go, every year we get a new contract, and when we sign our contracts, they used to go make us take them over there. Now we just give them to the secretary, which makes more sense because mail works. But so anyway, it's closed right now. You can't go in, so sorry. But if I want to add a value, I could just say MyD equals 2. And now I'm assigning the value 2 to that key. So if I print this, print MyD, well, actually, I'm going to put the whole thing. So now you can see that I've added a new key value pair to that list, well, to that dictionary. Okay. And then I can also let's see if let's see if a dictionary is mutable. Does anybody remember? Let's say Kelly, Arthel Kelly's estate was used to build another floor, another 2 floors. So Arthel Kelly's going to be a 3-story building now. Maybe remember what the term mutable was from the last time we met? Right. Okay. So I'm going to test here to see if I can alter the value for Kelly without changing it. What data types were mutable from last week? Was a string mutable? Well, no. We could reassign an entire string a new value, but we can't change individual elements inside of a string. And of the sequences we discussed, which one was mutable where we could change individual elements? No, tuple was like a string. It's not mutable. No, that's a good. I'm glad that you spoke out. That's awesome. So there's only one left that we discussed. The list. A list is mutable. We can say if MyD was a list, we could say MYD 0, and we could change that value. So I'm going to hit enter here. Okay. Turns out that the values in a dictionary are mutable. So now if I print MYD, I'll get that value there changed. Okay, Arthel Kelly Hall just grew another 2 stories. Now we can see the gas station roof. So pretty exciting stuff. All right.
Earlier you did colons, right? You're doing equals for the numbers.
Okay, so the notation for creating an entire dictionary at the same time is using the colons. So the notation for just getting an element is this, and then we know that this is the assignment operator, and so this is assigning that to that value. And just so you get the idea, we could actually assign. So this is the notation for a list, and we could assign the key Kelly a list value. So now if I print MYD, now Kelly is a list. These other two are still integers, they're still numbers, but Kelly is a list. So what's great about this is that we could use a data structure like this. And in a general sense, a data structure like a dictionary is called an associative array. So that's like the computer science term for it. So the reason why I'm telling you that is that if you were to program in a different programming language, they might say, well, the associative array data type in this language is called whatever. Python, it's called a dictionary. All right, so the nice thing about associative arrays is that we can use them to store kind of tabular information about things. So I've got a key and then a value, and that value could contain lots of different numbers. And in fact, the value could be very deep. So it could contain dictionaries of dictionaries of dictionaries of dictionaries. Now, in the JavaScript world, JavaScript is a programming language that people use to make web pages dynamic. There is a notation that looks almost identical to this, and in fact, in only one way is it different, and that's the way it expresses Boolean values. So it's very convenient for Python is actually used a lot for reading JavaScript object notation, which is sometimes abbreviated, well, actually almost always abbreviated to JSON, JSON. So this format for writing key value pairs is the same format that Python uses, that JavaScript uses to share information about objects. Okay, so from last week, and I did mention that we'd talk about last week a little bit. From week 3 here, we had this function that goes out and gets the URL from it goes out and gets some information from a URL. And I think I did show you this last week, but now that we have it up, maybe this will make a little bit more sense. I'm going to take all this information, copy it into a new file here. So this is the script from last week that finds the location of an address. Okay, right now our address is just Hattiesburg, Mississippi. Google will accept all sorts of addresses. I'm going to save this. I'm just going to save it somewhere random because this already exists. Let's see. Put it in ctemp. I'm gonna run this, but before I actually run it, I am going to I'm going to print the result. Print location, and then run this. So you can see all this here, not this part, but the rest of this, all of this, is what was returned. So at that URL, that's what was given. So it's not a URL that you would go to view a web page. It's a URL that just returns a text string, a bunch of text that can be read by JavaScript, but also by Python. Python interprets it as a dictionary. JavaScript interprets it as a JSON object, JavaScript object notation. But now that we know how to read a dictionary a little bit better, we can see that this is a dictionary. That's what the squiggly bracket means. And the fact that it says, quote, status, what is this? What is this thing? That's the key, exactly. And the value that goes along with that is okay. Okay. Now there's a second key. There's a key called results. What's the value in results? Yes, it's a location, but specifically in terms of Python, what does this open bracket mean that it is? What? Exactly, it's a list. And so results is a list. And I'm pretty sure that it is, trying to find if there's another, it's hard to see in this format. Types is another key, yeah. Yeah, well, I mean, technically, geometry is a list. I mean, geometry is another key, but that key is inside of this list. See what I'm saying? So I'm trying to find out where this list ends, and it's hard to see because of the format. Now, if you actually took this, yeah. If you actually take, I think we did this last week, but if you take this value over here and say question mark address equals Hattiesburg MS. Oops. It's this first quote that's messing it up. All right. Address equals, there we go. I'll change this to Hattiesburg, Mississippi. All right, so that's what we're seeing. So results is this list, and inside that list is a dictionary that has all these key value pairs. And it looks like that ends down there. So these are all elements inside of address components inside of this list. All right, so there's just a single item in the list. So what I've done here, and this is just to drive home the point that you can have these very complicated key value pairs. We're not necessarily going to. We're going to use some simple key value pairs. What I've done here is like, okay, I took the response and I looked for the value results in that dictionary, and I took the very first result, and then I asked for the geometry, and I asked for the location within that geometry, and then specifically the longitude within that geometry. So this was actually a dictionary inside of a dictionary, inside of another dictionary, inside of a list, inside of a dictionary. So that's what all this looked like. So this dictionary that had the key lat is inside of the dictionary that has the key northeast, which is inside of this dictionary that has the keyword bounds, and so on. Okay. So sometimes when you're reading things like this from the internet, you have to read through a few items. Okay. All right. So week 4. So another, I mean, yeah, I said they're sometimes called associated arrays. Sometimes they're called hash tables. I didn't mention that. I did cover the fact that the keys have to be unique. In other words, if you try to take a value and assign it to a key that already exists, what happened? Yeah, it's replaced. It doesn't create another key. It replaces it. And values can be of any type. For example, they could be tuples. I didn't actually show that, but I did show they could be lists. You could use that to store any type of tabular information. Okay, the book has an example of them being used to store information to build bar charts or histograms. And then I mentioned how dictionaries are basically JavaScript object notation. And I forgot to say that the only difference, no, I didn't think I did. The only difference was the way Boolean values are stored. Python capitalizes the T and JavaScript does not. So technically, if you were to read straight JavaScript and it had some true false values in it, you get an error. But there are routines for doing that without getting errors. All right. Okay, the next thing that we're going to talk about are yeah, I'll talk about modules next. All right, we've imported modules already. What are some of the modules that we've imported? Right, we imported math and URL web. I'm not sure which one you're pointing at, but we imported both of these. Now we know what the math module does. What does it do? Right. Okay, what does the URL lib function do?
Follow a website code or web address.
Right. And there are basically three categories of modules. Modules that are built in that come with Python, they're called standard modules. URL lib and math are both standard modules. They come with Python. You do have to load them separately, but they exist inside of Python, and you don't have to go download them and install them separately. Okay. The second category are those modules that are created by third-party entities. Now, Python itself is actually open source. It means it's free to acquire, and you could theoretically go look at the source code for Python. It's written in C and C++, but you could modify it, change it to your own needs. There's really no reason for you and I to do that, but what it does mean is it's free, and this sort of free software type of a niche that exists out in the world promotes lots of these third-party modules to also be free, okay? And so some examples of third-party modules are the ones that we'll talk about later, but one of them is ArcPy, which is the ArcGIS interface. So we can load ArcGIS functionality right up into Python. Now, what I just said about things being free doesn't apply there. The SRI still wants to charge for their version of the software. So whether or not you're using it inside of Python or using it inside the graphical user interface, you still have to pay for their code to run. However, and we will discuss these in class, there are lots of people who have written routines that are very, very similar. In fact, sometimes they perform faster, sometimes they don't. They're not always better, but there are, and they're not always as complete, and sometimes it takes a little more effort to uncover them, but there are tools out there to do GIS routines. What do I mean by GIS routines, by the way? Yeah, things like overlay or selection inside of a GIS group, or buffering, proximity functions, things like that. Spatial thing, and we'll definitely have a review of those types of things next week. but there are people who have written written routines that are free to use. I'm kind of mixing this part with this part later, but that's what that's what GDAL is. It's open source GIS tools, and there's a couple of sub modules inside of GDAL. And then, has anybody here used PostGIS before? Okay, PostGIS is kind of like a GIS software and database software together in one. We'll cover that a little bit, but probably not too much. But there are modules for interacting with Postgres and PostGIS, and we will use these two, NumPy and SciPy. Those are some external modules that are free external modules for dealing with large sets of numbers. And it just so happens that GIS is sometimes can be thought of as a large set of numbers, so those make sense. And we'll leave the rest of these to when we discuss them, but you can see the description of what each of these does. You can make plots and graphs. Basically, you think of a software package that does something that you like, and there's probably a Python package that either interfaces with that piece of software or provides the same functionality inside of Python. And this list that I've come up with here, of this list, only ArcPy is a commercial software that requires a license. The rest of these are all free. There are some where, like Pillow, where they're developed by a company, and you can certainly pay that company to for support of that software package, but it's not a requirement if you just want to try to muck your way through it. Okay, so back up here to modules. I've talked about two types so far: the standard ones, the ones you can download and install, and then finally the third type is that you can write your own. Okay, and I'm going to demonstrate that really quickly. Sorry, was there a question? If there's a question, stop me. All right, and I'm going to just file, save as. I'm going to write over this, and I am going to write this into a different directory. I'll write this into the directory we've been working on. C courses SPA week 4, and I'm going to call this 2016 underscore. I'll call it modules example. It might be better than calling it example 1, example 2. I'm going to delete everything. Okay. And I'm going to make this like that. And I'm going to have another new file. So I've got a split window here. I'm going to file, save as, and I'm going to call this, actually I'll just bring up. I'm going to open up my mod, and I'll leave it there. If you want to type it in, it's a pretty short mod. Or if you want to, just this is available on the GitHub site. And what does this function do that I created? We should be familiar. We've used it. Yeah, distance from point to point. Okay. You probably looked at this and said, "Oh, it's so boring. We're talking about distance." So this is just an illustration. It's an illustration. It gets the distance from point to point, and the way it's used is down here. And you can write a module like this. This is my new module that I'm just writing. And if you use this syntax here, you can test the elements in the module. So most of the time, a module is nothing more than a big collection of functions that you don't want to store in your code because it just gets too cluttered. It's a way to like separate out some of your code into different files. So you don't, I don't know, maybe you have already had this experience, but with the assignments that I've already given you, you may be like scrolling up and scrolling down and trying to find where you were in your code. Well, one way that people like to kind of break free of having to find a bunch of lines in their code and find the exact place is to separate it out logically into different modules, okay? Now, the drawback to this is that sometimes you're like, well, which module did I put that in? And so you gotta find out which file you put your code into. And so sometimes it's a balance, okay? Most of the things that we'll write in this course don't involve humongous sets of humongous lines of code, a humongous amount of lines of code. And so writing separate modules may not be important, but if it is something that is helpful to you, this is the way you do it, and that's why I'm showing it to you, okay? So I've got this other blank file over here, and I'm going to, what I'm going to do is call the code that's inside of my mod. It's inside this area. I'm going to call it in this window, in this set of code, okay? So the first thing that I have to do is import it, okay? Now, the way that you import another module that's basically another Python file is you just call it by name, except for you don't put the .py extension on it. So I can import my mod. So now if I say import my mod, it will import this, okay? Now, you do have to save. You don't have to save it when you actually go to run it. I have both of these saved already, but yeah, you'll have to save it before you go to run it. And you'll have to save it before the colors show up. So now if I import my mod, I'll be able to access any function that's written over here by simply saying my mod dot distance, and then I could say 4,2 and 7,10. So now I'm gonna want to print it to show that it works. So now it's going to access this function that's inside of this file, and it's going to run it inside that file. Okay. So if I run this, it will work. Now, it might not work for you. I forgot to explain one thing. I was saying it right as you were asking me about saving, or I thought about it right as you were asking me about saving. So thanks for doing that. The module, this module has to be in the same directory as this file for it to work. Okay? Sorry, you say both on the desktop?
If I save them both, then they'll just go.
Yes, as long as they're saved in the same folder. Now the other thing is it checks the same folder first. But if you did create a, let's say you create a module that you wanted to use all the time on every single time you wanted your Python, on your Python installation, you could put that into the lib folder. You could put that file here. So you could put your internal modules, you could put them in this folder, and then you would always be able to access them in this C Python 12 ArcGIS 10.3 lib. Okay, we're not gonna do that here. So if you want to do it, just put them in the exact same folder. It's probably the easiest way, and that's the way you do it for testing. And then when you wanted to go deploy it on somebody's computer, you would say, okay, here's a bunch of files that I want you to put into that lib folder. And then here's the file that you actually run to get this to work. Okay. Now, in the end, if you were an actual software developer, you might create a tool that would that would just take your files and unzip them and place them in the right locations. Okay. We're not going to cover that as part of the course, but getting you partway there on that. So, all right, anybody have any questions about modules, writing your own modules? You've got, you're utilizing it in this file, you've written it in this file. Okay. So usually the way you do it is you write functions that you access, rather than you don't have variables in this file. You could have a variable in this file, like I could say, you know, oops, didn't mean to be way down there. I could say thing equals 0. Then I could access pretty sure this will work. Of course, there's not too much application for this, but I'm just showing this as an example. Yeah, it works. Okay. So it's 0. Okay, I could have variables in here, but oftentimes that's not the way it works. Those would be like constants. In fact, there's an example of one of those in the math module. Anybody, did we use it? Maybe think of what would be an example of some constant that's in the math module. Yeah, exactly. So if I imported math, you can import 2 at the same time. Pretty sure this will work. So this is just a variable that sits inside of the math module, okay? But I don't know that there's too many applications for that, but there's certainly values that, there's certain things like that, that there's certainly some applications for it. All right, I think I have shown this before, but if you import a module, you have to keep referring to one of the functions or one of the items in the module by using this dot notation. So the name of the module dot the name of the item in the module. If you did this, if you said import, if you said from my mod import star, what you're saying is that I don't want to have to use, did we talk about this before? I don't want to have to utilize the, so it still works. I don't want to have to utilize this mymod dot extension. The problem with that is what happens if you open 2 modules that have the same, that have the same function named in them. So you have my mod with a function called distance, and you have Joe's mod with a function called distance. And so then you have ambiguous, you have 2 different distances in there. So typically it's best to just say import my mod, import the name of the module, okay, and then use the dot notation. But if you can be sure, either you're only utilizing one module, or you can be sure, then you can use this, utilize this notation. You don't have to keep typing my mod throughout the remainder. Kind of a compromise is you can actually just import a single element from a module. So this will work as well. So I covered importing an entire module, importing just, all of the elements, but not having to use a dot notation, and then importing simply one item from a module. Okay. So with ArcGIS, you can do the same thing. Any module, whether you wrote it or somebody else wrote it, or it's a standard module, these all apply. So I could say from math, import pi, and then I could just say print pi, and it would print just pi. Okay. I'm gonna, sorry, it was a question?
Yeah, I don't know if it works. It's still not working. I put them in the same file.
You put them on in the same directory? Okay. Why don't you zip them up, or there's just 2 files. So attach them both to an email, and email them to me, and then we'll look at them together. This would be great. And I'll look at Caleb's what you're sending it to me.
So here it is. Import, it's got a trace back. Didn't try to be GHY. I tried to just regular.
Right.
And
So
save them on the name.
So sorry. This is the location that you stored it. This is the location you stored it.
Right, that's fine.
Yeah, but the problem is they both have to be Python scripts rather than, so you're accessing it through the interpreter. So you need another, maybe that's the same. Now if you said import WEK4 and then now type in yeah, but you have to save this. Save it. Save it in, is this the location you're working in?
Yeah.
Where's WEK?
Where's that one? Yeah.
This has two E's.
Oh,
This only has one.
Oh, because it's not.
Maybe it isn't.
It's not a Python.
Okay.
It's just that's why.
Try to save this as test or something. Test.py. Save. Run that. Save that .py. Okay, so now it's working. It's just printing the fact that it's a module. If you could write print WKE4 is or dot distance and then put something there and it's really insane is fine. All right, so were you able to, let me look. Which email address did you send it to?
I sent it in, but it's
Okay, so we had a similar, well, at least a similar symptom here with Caleb, and he didn't name it .py, and so it was having an issue. So I'm not sure if that's your issue. We'll look. It might be different. Okay. Yeah, then why don't you go ahead and send them up, and we'll take a look at why it's not working. It'd be really nice to get some like software we could see everybody's. This will be pretty easy. I mean, it should. If it doesn't work on one machine, it's. It doesn't matter, but yeah, I can pull up either one. I've actually got one open in Internet Explorer right now, and the other one open in Chrome. So. Sounds good. Do that one. That's the one I've got open in Chrome. Some of these I just, like, I've never even shopped at Pottery Barn. I have shopped at B&H and buy stuff there. There it is. All right. Okay, so I'm going to just go ahead and copy this folder, which is probably, let's see, I'll just put it in temp for now. Paste it in there. I'm going to rename this folder mod test or something. Okay, so I'll look at my mod first. Okay, I'm going to run it just to make sure that it works. Okay. Oh yeah. So you probably copied and pasted this off of the internet, which made this indentation not exist right here. That might not be the old.
I typed it, but whenever I typed it, enter, it just print purple. I thought that was an error.
Okay. Yeah. So the first thing I did was import indent that. So maybe that, but that might have been the only mistake. So let's look, or the only bug. So that's the first thing I did. Now if I run my mod, yep, it doesn't do anything. Oh, this should be, sorry, I messed up and put that T there. Okay, so now we know that it works. So this is the way it should look. I messed up and put that T there, sorry about that. This does have to have an indent though. Okay, so now that we know the my mod works, let's look at the modules one. Whoops. Okay, so yeah. All right, this was the same thing that Caleb did. I'm sorry. So this must be confusion on my part that I created as a teacher. So here, what we want to do is if you open that back up, that modules 1.py, and delete everything that's in there. I wasn't running this from the interpreter window. So now you could say import my mod, and then say print my mod dot distance, and this is in a script file, and then type in some numbers, 5, 6.
It's hard to see. It's not like the black part of the screen, where the projection is on the black part.
Oh yeah.
If it was the model or if it wasn't.
Okay. Yeah, because you can't see the brackets.
I have the whole screen.
What's on their screen? See, they can't even see the first letter of the B.
But I'm saying, can you pull that little window over just a smidge, so it's not a full screen window?
Oh yeah, on my end.
Yeah.
Okay. Yeah, so I think maybe that is the best way to solve the problem. There we go. So that's probably good. Thanks, Dale. So yeah, we've done it. Done it all. All right. So that make more sense. Do you want me to zip that back up and send it to you, or does it work on your end now? Awesome. No problem. Okay. Okay, back to what we're talking about. All right, so that's really all we're going to discuss on making our own modules. There's not even a homework assignment on it. So if it helps you out, it helps you out. If it doesn't, then that's fine. Okay, so I'm going to close this up and close this guy. I'll say yes, and then go back to the screen right here. So now we're through modules, and the other item that we're going to discuss kind of quickly, and we are actually going to, part of the homework assignment is going to involve classes, but we're going to do that part right now together as class. We're going to do that when we create a class. So basically, we've used objects before. An object is those things where access an item using that dot notation. So, and we'll get into this a lot next week when we start using ArcPy. Okay, the ArcPy itself is a module, but there are objects that we interact with when we do that, when we use modules. So a class is just a general form of an object. And objects have properties, which are basically variables that an object can have, and they can have methods, which are basically functions that a object can have. Okay, and so we're typically not going to create our own classes, but it does help to understand how classes are created in order to understand how to use them. So we're gonna practice, and to do this, we're gonna create a very simple class that's a point. Okay, what's a point? What do I mean by that? Like, as a geographer, what do I mean by point? Right, yeah, so I'm not talking about like a sharp object. There's few definitions of a point, but we're talking about a place. Okay, what do I need to do to describe a point? Right, exactly. We need an X and a Y usually. And typically, when we're talking about a projected coordinate, the X and the Y represent a location on a Cartesian plane. If we're talking about a unprojected coordinate, it represents a latitude and longitude. However, in lots of computer representations of points, they kind of ignore the fact that there's the two types of points. Not everyone. In fact, it's becoming more and more common to have geographic points, which are referred to as latitude, longitude, and just regular points, which are X and Y. But in our case, we're going to kind of ignore that. And an X coordinate would be kind of like a longitude, and a latitude would be kind of like a Y coordinate going up and down. Okay, so I'm going to make sure this is not off the chart there. Yeah, okay, there we go. So I've opened up a window, a script window, and we're going to utilize this script window to create our class. So the way that we create a class, and we're going to create a point class, is just to use the keyword class. And then the name of our class is going to be a point. So I'll call it a point. All right. And our point is going to, for now, we're not going to put anything in it. And just like with the other elements that have a colon behind it, we can press return here and have a series of code underneath that, and that's going to help us to define our class point. Second, see courses SPA week 4. I'll go ahead and save this. Oops. Yeah. I'm going to copy, and this is last year's information. I'm going to go ahead and copy that into here. Just because I wasn't 100%. Oh, wait. Let's make sure I see. Courses. I'll bring this back up in just a second so you can copy it down. See, SBA week 4. Yeah, sorry. So you actually don't need this little guy right here. Okay, so let's go ahead and explain what's going on here. Okay, Python doesn't really, I'll explain it when you type it up, and Python doesn't really care how much indentation you have. I probably have too much indentation here, so I'm going to delete one and then delete one here and delete one here. All right, so a class is defined by a word, and this is the name that you're going to use to refer to that class from now on. When you actually create your own point, you'll have to come up with another variable. You'll create your own point by saying something like my point equals a new point. Okay. So here's the syntax for that, by the way. So I'm creating a new point right there. Okay. So a class can have various functions inside of it that can be used to do things. We're going to put a function called, it's a special function, and it's called underscore underscore init underscore underscore. When Python sees this, it knows that this is the function that you want to run whenever you create, or when you create, a new instance of that class. In other words, a new point object. So here you're going to say, okay, here's my new point, and this function, it's going to pass itself as the first parameter, and then any other item that you want it to pass in. And if you say equal to something, that's going to be the default. So in other words, what this is saying is when you create a new point, the user will have to pass in an XY location. And if they don't pass in an XY location, you want the location to be 0, 0. Okay? And then what you're doing inside the function is only assigning those values to self.x and self.y. So we've created a very simple class, and we can create a new object, a new instance of that class. I'm saying that on purpose. I'm saying both. An object is an instance of a class. So when I create a new object or instance of a class, I can simply say, you know, my point is equal to point, and then I put in some values. Here I can say 3, 4. Okay, now if I print my point, it's going to print out something, and it's going to be kind of cryptic. Let's run. I'm going to file, save as. I'm going to call this C courses SPA week 4. I'm going to call this 2015 sample 1.5. Oh, 2016. All right, so now when this runs, it's going to print this cryptic thing. That's the way objects print in Python. If we want to inspect the individual values, we have to refer to the individual values. So we have to say something like myPoint.x. Now, if I run this, I'll get a better thing, and it says it's a 3.0. By the way, why does it say 3.0 here instead of 3, which is what I put in? Right, inside of the definition for that function, the function definition for that class, I converted whatever they put in to a float. So I can also say my point dot y and run it. Okay. All right. Now at this point, maybe, I don't know, but maybe you're asking, why didn't I just create a tuple or a list? Because a tuple and a list would do pretty much the exact same thing. I could still access these things as self 0 or self 1, or I could even make it a dictionary and say self bracket quote x and quote bracket quote, something like this. I could do something like this. My point equals x. Right? And I could say print my point. In JavaScript, I could actually do the exact same notation, but you can't in Python. You have to do this. Okay. So that will work, and it'll print 3 as well. So 3, 4. All right. So what advantage does doing this have to do with doing that? Well, in some cases, there may not be any advantage to doing this versus doing this. However, there are some advantages. I'm going to show you one. So I could have another function in here called translate. What does it mean to translate a point? Right. My weakness here is going to be spelling everything right. Okay, so can you kind of get an idea of what this translate function is doing? If I put in an offset and in terms of x and y, and I don't actually have to put both values in, if I put in that offset, it's going to take those values, and it's going to move my point around by this x and y shift. Right, so now I'll demonstrate that working. I'm going to go ahead and comment out this line of code, these lines of code, so they don't confuse people. All right, so I'm going to create my point here, and then I'm going to say my point dot translate, and then I'm going to translate this by 4, 5, and now I'm going to print both my point x and my point dot y. Okay? So what should my point x be when I finish running this? And y? Yep. So I'm going to run this. Mess up here. Oh. Two, 3 given. X, Y. Yep. Okay. So that ended up right. 7, 9. I messed up. I forgot that although it's not explicitly like this, looks like there's only two parameters going into this function. In reality, it always passes a reference to the object being manipulated, just so that you have a reference to it. So you need to include that. Anyway, so now you're probably not going, again, this is kind of like our discussion of modules. You're probably not going to need to utilize this a whole bunch in this course, but if it helps you, great. You could have made everything a dictionary up here, and you could have had a separate function that translated points or translated dictionaries, okay? This just demonstrates the power of an object. An object can actually do things by itself. It contains both functions and variables inside of it. Okay, that's what makes it an object. And people that program using utilizing mostly objects are referred to, or that style of program is referred to as object-oriented programming. Okay, so Python allows for object-oriented programming, and you could make all of your code object-oriented, or you can make some of your code, which happens a lot more in practice, in everybody's practice. Some of your code is just utilizing variables like dictionaries and making them almost object-like, but you have to write a separate function to do something like translate, whereas if it was an object, you could put a function inside of your object to do the translation. It's basically just a programming style. It probably involves a little more thinking and planning up front to do pure object-oriented, but it can be organizationally helpful. Okay. So we could have another function in here that instead of translating it, it has an angle and an offset. Think of that might be really powerful. So I could tell a point, wherever you are, go to 90 degrees or 30 degrees or 15 degrees, and then go 15 and move yourself over there. Okay. That would involve some trigonometry, right? But it could be done pretty easily. But anyway, I wanted to show you an example of creating a class and then utilizing that class. So this is that, and we are actually going to utilize this particular class today in the homework. Okay. So we'll circle back to that after we discuss files. All right, any questions about that? Did I not leave it up long enough? That'll be included in the GitHub, so you'll be able to see that later. All right. So we talked about how you create a class, and then I say here, we're really going to be consumers of classes, but it does help to understand how classes are created, and also does give you the option that if you want to, for your assignments, to create classes. It's a great tool. If you have a very large programming project, like if in other words, I'm envisioning that many of you will take what you've learned here and mostly utilize this to automate simple GIS tasks, or even complex GIS tasks. But most of you won't be writing your own new GIS software routines. But if you were, creating classes would definitely be an advantage. And so that's why I introduced this as part of the course. All right. So the last subject that I really want to discuss today before we go into the lab is this concept of a file. Okay. Now, there are all sorts of different files out there. We know there's like, what is a file on a computer? Yeah, it holds data. It holds data that's, and lots of times the way that computer scientists refer to it, it holds persistent data that we want to persist through time. If it's not in a file, it means the data is in memory, and usually that implies that when that particular program stops running, or when a particular routine stops working, that it will no longer exist, or it will be impossible to access. So files store information about, that needs to be persistent, that needs to be collected at a later point, or shared with somebody at a later point. And there are lots of different types of files. And when we talk about ArcGIS next week, we'll talk about, GIS files. ArcGIS, the ArcPy function, the ArcPy module is kind of going to abstract the concept of the file a little bit. In other words, we're not going to need to learn how to read and write ArcGIS files. We're just going to say, buffer this and then put it in this file, and we're just going to name the file, and it's going to put it in that file. Okay. However, it often becomes important for people that are doing the kind of work that we do to generate let's say a report. Like if we want to buffer, let's just say we're going to do something simple like find out how many people are served by a proposed new grocery store, and we want to find out how many people are within 10 kilometers, 20 kilometers, 30 kilometers, 40 kilometers, and 50 kilometers. Okay, so one way to do that is to buffer at 10 kilometers, 20 kilometers, 30 kilometers, 40 kilometers, 50 kilometers, and then do a few other GIS operations and come up with a number. And we might want to store a simple file that has, the number, like it might look like this. It might look like this, 10, 20, 30, 40, 50, and then it might have a value of, 22, 453, oops, probably get bigger. And those are the numbers of people that are within that service area. Now, we could learn how to write an Excel file, but luckily Excel reads standard text files. And that's mostly what we're going to talk about is reading and writing. Actually, that's all we're going to talk about. Reading and writing text files, because text files can be utilized in lots of different things, including Excel. Everybody can, pretty much everything, including ArcGIS, can load what we call a comma delimited text file. Okay. Yeah, CSV. So we'll talk about reading and writing those. All right. So that's what we're talking about here, reading files. Yeah. So I'm going to create a new example here. I'm going to say file, save as example 2. And example 2, I'm going to read a text file. So I'm going to delete everything here. And the text file that I'm going to read is also located in that same directory, and it's called, so if you need to download it, I just need to see what it's called, C courses, SPA, week 4. The file that I'm going to read and write is called citiessmall.txt. I'm going to read that file. All right, so to open up a file, I always like to make sure I'm getting the syntax here right. I'm just going to Google read text file, Python. All right, depending on the machine that you're on, if you've Googled the same thing I did, you may have to change the version of Python that you're referring to. Just make sure that it's a 2 version, 2.6 or 2.7.11, and not 3. And if you scroll down a fair bit here, they're reading and writing files. Okay, this help starts off writing files. We're going to start off reading files. So here's the syntax, the example of reading. Of course, it didn't actually show opening it. So I'll tell you that it looks just like this, except for one letter is different. So I'm going to copy and paste that here. So here it says F equals open. Open is the name of the function that's going to open up a text file. This is the name of the file, okay? Work file. What type of variable is that? What type of thing is that, work file? Well, keys are often strings. It's a string, right? All right, now, if it's stored in the same directory as C courses SPA week 4 2016 example 2, we're okay. So in other words, if there's a file called work file, it's going to open it. But there isn't, so it's not going to work. By the way, I need to change this to R. R reads, W writes. Okay, so what I'm going to do is copy the entire path to the file that I'm working on, which is like this, and then it's called city small. Spell that right? Small.txt. City small.txt. I'll leave that up for a second. All right. So I've just put the whole path, and lots of times it's good in practice to put the entire path to that file, and you can find that in Windows Explorer. So this is going to open up citysmall.txt for reading. Now it's important here that you actually change this R. I mean, this was a W to an R. If you do not, Python is not friendly and asks you, do you want to write over that file? If you open it up for writing, it just writes over it. Okay. The only exception is if it can't write over it. In other words, if you've set it up as a read-only file or something. But unless you've done that, if you put a W there, it will write over that file. So you don't want to do that. It'll write over any type of file too. So if I put the name of a shape file, or if I put the path to a picture, my only picture of one of my daughters, and I put .png and whatever, and I put a W here, it would overwrite that file, and it's pretty much gone. So don't put the W here on a file that you don't want to lose. All right, so this isn't going to work right the way it stands because slashes in Python are special characters. I'm gonna show you that by running it. Make this a little bit smaller. It did work. I didn't think it would work. It worked again. Okay. So maybe it's the other direction that's special. I'm gonna try to run it again. No? Okay. I honestly don't know why it's working, but it is working. To be careful, what I like to do is if you put another special character in front of your string, and it's the little R, I always like to put the R in front. And if I put the R in front, what it tells Python is to ignore any special characters. Just treat the string like a string. So oftentimes I'll put this R in front so that it will read it right. Okay. It's not doing anything right now. All right, now what if we want this to do something? Well, there is a function. Once we do this, f becomes an object. In fact, I can say print f, and I'll run this again, and it tells me, look, see that notation with the it opens with a caret and closes with it opens with a less than sign and closes with a greater than sign. That's an object. So it's an open file, and we can do stuff with it. One of the things that we can do is to read from it. So we could say, okay, I want to get all of the contents of that file and store it in a new variable. I'll call it contents. And say that is equal to f.read. and I'm going to print the contents. So now I'm going to open the contents. I'm going to save them in this file called contents, or I'm going to read them into this variable called contents and print the contents. By default, all of the stuff in this file will be read, and it will all be a string. I'll show you that. So this is the information contained in that file. If we can prove that, actually, by going there and double clicking on it. So this is the information in the file. See that? See that? I'm not exactly sure what these little special characters here are, but there's something in the file that's being interpreted as those weird characters. I'm not exactly sure why, but it doesn't really matter. This is the header. So really, eventually we're going to ignore that that field anyway. All right. So we read in an entire text file as into one variable. That's what we did here. That's what we did here. We read the entire contents of this file into a variable. Now, in reality, most text files are organized line by line. What do the lines represent in most text files that we deal with? Like in this case, in a general term, what does each line represent? Yeah, a piece of data. A record is another way to say it. Or an entity is another way to say that. So if we were medical doctors doing experiments, these might represent individual people. If we're geographers, they could also represent individual people. Let's say we did a bunch of interviews. They could be individual people that we interviewed, and they could the things in between the commas are often attributes of those individual entities. Okay? So it's sometimes in computer science world, this is referred to as a flat file format, where the rows represent entities or records, and the columns, the comma separated stuff, represents attributes. It's actually identical to what we refer to as a table in ArcGIS. Okay, they could represent counties, they could represent cities, but each line is one entity. So there will be times when your data is organized like this, but it's not organized in a GIS format yet. It's organized in some case like this, and you could read it in. Now we've read in the entire thing. Oftentimes, it's much more productive to read things in row by row and process the row as you're reading it in. So in other words, if you have to do something like store that information in a table or manipulate that information somehow, like let's say you have to translate the location of a point or something, as you read in every individual value, then you'd want to read things different than this, because this reads the entire thing, or optionally, it reads, I'll show you anyway, just not popping it up anymore, but there, it popped up for a second. It's not going to do it again. But there it is. It'll read the number of bytes, but that's fairly useless when you're reading a line file, because you don't know if the line is 20 characters or 30 characters. By the way, this isn't totally important, but does everybody know how many bytes there are in each character? You said 8. That's a good answer. There are 8 bits in each character, so every character is 1 byte. So if I did something like put 5 here, I'm reading 5 characters, and now if I run this again, you'll see that I've read the first 5 characters, which are this character, I don't know what these characters are, and then the CA. So it's the first 5 characters here. 1, 2, 3, 4, 5. I highlighted one more. Okay. So you can use it to read a specific number of characters. What's interesting is that if you read a certain number of characters and you read a certain number of characters again, it's going to continue. And that's the expected behavior. So the first time it read the first 5 characters, and then the second time it ran the next 5 characters, and it will continue to read until it reaches the end of the file. Okay? However, in practice, it's not that common, but there might be a case. So it's good to mention this. There might be a case where you want to read a specific number of characters. However, oftentimes it's more practical to do what we call read line. Okay? And read line will read one line. So now if I say print contents, it reads the entire first line. And so it read and printed canonical name. It read the entire first line, and that first line actually included a carriage return in it, and so it printed that carriage return too, and that's why there's a space. Okay. Next step. In practice, oftentimes it's even done more often to read the whole thing line by line, and we can do that using a for loop. For, I spell for, right? For a line in F. Print line. So now we're saying, okay, in this open file, I want to read every line and then print it out. Now if I run this, it's going to look almost identical to this, except for it's kind of pointless to explain, but if anybody wants to. By default, it puts a space in between each thing that you printed. It puts a carriage return, plus it's already printing the carriage return. So that's why there's space, there's a carriage return in between each line, because it's printed an extra carriage return. I mean, that's not really important, but but we've printed everything. So we could print each line. One of the things that we could do, like, is say print line dot split, comma. All right. What does this function do again? Do you remember what split does to strings? No, I mean, that's not a bad guess, but it's not actually what it does. It takes a string and returns a list of all of the values that were separated by commas. So if I run this, you'll see it's going to return 1, 2, 3, 4, 5 lists. And the lists have everything that was separated by those commas. Now, what do you suppose this is right here? What's that? It's a carriage return.
Yeah.
So it's the special Python way to indicate a carriage return, /n. So if you ever want a carriage return to show up in your text, remember Python's finicky about indentions and all that, you can throw this in there. I'll show you. So I'm gonna open up the, I'll go to the interpreter window for a second and say A is equal to George carriage return Raber. Okay. Now if I print A, it printed George, carriage return, space, Raber. See how it did that? If I took this out of there, now if I print A, that's not there. Or if I wanted to have, 5 carriage returns, which would be ridiculous, then there's 5 carriage returns in between. Okay. So that's an example of a special character. That's why I actually thought that this wouldn't work, because that's slash things. But maybe a slash C and a slash S and a slash S, none of those are special. In any case, when you put the R in front of it, it will ignore it all anyway. Okay, so we're reading every item in a text file, and we're actually printing off a list. So I could do something like this, where I said, okay, I only want to see the first thing. So now I'm printing off just the city name. Okay. There's a function called trim. Let's see what happens. I don't think this is going to do anything. No. Is it called trim? Just a second. I'm going to look at my notes. Those are here. Nope. Where did I leave my notes file? There it is. Strip, sorry. Trim is probably what they call it in JavaScript, and in any case, it's a different language. So yeah, strip is the right command. We haven't done this yet. Strip takes leading and trailing white space, and it cuts it off. There is no leading or trailing white space in any of these values, but it's often helpful for reading text files to remove leading and trailing white space. So sometimes you'll see something like this. All right. Okay, so we covered read lines. There's another one called read lines, which will read a certain number of lines. Again, the one that you're probably going to use most often is either read line or using a for loop to write to read the lines line by line, and the strip function removes leading or trailing white space. Here, I'll show you a little bit about what I mean there. You don't have to do this, but let's say I take city small and I open this up and I add a bunch of spaces right here, a few spaces right here, and I hit save. And I run it, and I go back to my Python and I run this again. It has these weird characters here that I'm not sure, but you see the other spaces that I added before Anderson, they're gone because they were leading or trailing spaces. All right. Really wish I could get rid of those spaces, but like I said, it doesn't really matter. Okay. All right, now let's practice writing files. Okay, again, it's pretty easy. All we have to do is change our program slightly. I'm going to save this file, save as, and I'm going to save this as example 3. And we're going to change this R to a W, and then I'm going to call this output test. So I've got I'm going to save it in the same location. I don't have to call it a text file. I can call it a CSV file. It doesn't really matter. In fact, let's do that this time. We'll call it a CSV, output test.csv. And the way that I write is just the opposite of the way that I read. So I can say f.write, and I can put in some text. Hello. The one thing that you have to do when you write is you have to close it. When you read, you can oftentimes get away with it because once it runs through the file, when Python executes, it'll close it for you. However, if you rely on that when you write a file, it will not save the information into the file, okay? So you actually have to tell it to close for the information to stay in there. So if you say f.close at the end, then it will store that information. So now if I run this guy, it'll run through, and I should, if it worked right, have a file in my directory versus, no, C courses SPA week 4. I should have a output test.csv. There it is. And right now it only contains the word hello. But it did work. It created that file. I could also make it work line by line. I'm going to close this and go back to Python. There it is. So I could tell it to write a line and put that there. I think that works. Okay. Oh, let's make sure this works. Okay. So there's actually no write line command. You actually have to do this. So that will write 2 different lines. Run that guy. And now if I open that up in it didn't work. Didn't run. Oh. Did I do something wrong? Maybe I didn't actually run it. Yeah, it looks like I didn't actually run it. Sorry. So now it says, hello, everyone. I wrote 2 lines. Okay. One more thing. Let's take our original example. I'm going to open that back up. That was, I didn't even store that right. This one? No. Okay, well, I don't have it anymore, so I'll just retype it. Be quick. Okay, our original example here, we had MYD equal to, this is what I'm talking about. Okay. 1, 2, Johnson, what did I say, 12, and Lucas, 2. Need to put that in quotes. So this was my dictionary that I created before. You can find it and just cut and paste. It doesn't really matter what the values are. What I'm going to do is demonstrate writing this into a comma delimited text file. Okay? So the first thing that I might want to do is just put the header in place. So I do something like this. Building, comma, then the stories. Yeah. Okay. So put something like that. Then what I want to do is do something like this. For MYD, or for BLDG, that's just the name of a variable, in MYD, do this. And I'm going to, what am I going to do? I'm going to write the BLDG, and then I'm going to write, put a comma, and then I'm going to put the stories. So I'll have to put, how do I get the story out of my dictionary? Like this? Now remember, to access the elements in a dictionary, I don't reference them by numbers. How do I reference them? Anybody? Okay, let's just say I wanted to get the value of Kelly. How would I do that? MYD Kelly, right? That's how I get the value of Kelly. So let's generalize that. We want to generalize this. The first time through this loop, what is BLDG going to equal? This is for each key in my dictionary. So the key, what's that? That's a good guess. And you're saying one because Kelly is one story, right? Is that right? Okay. Now, why were you saying one?
Well, I was thinking that, were you asked what that building was going to be?
Yes, the value of building. Watch this. I'm going to comment out this line, this line. I'm going to comment out all the lines except for this loop, because maybe this loop is throwing everybody off. Okay. I'm actually going to print BLDG. I'm going to print that. So what we're going to do is see what values are going to be printed. Now I've already told you this is for each key. Okay. We're gonna show what they are. Kelly Walker, Lucas Johnson. You see that how this loop printed Kelly Walker, Lucas Johnson. I remember I told you that the order that they actually store in can't be predicted. So they printed Kelly Walker, Johnson, Lucas. Now watch what happens if I do this. MYD. How could I? What I want to do is go through and figure out how to get the value that's stored there. So what if I did this? So what is this going to do? MyD bracket BLDG. What's that going to do, you suppose? Get it? Right. Exactly. It's going to give me, a more general way to say that is, it's going to give me the value in that key value pair, right? So this gives me the key, and then this is the way to get the value from the key. So now if I print this, that I'm getting Kelly 1, Walker 2, Lucas 2, Johnson 12. So just this, if I delete this again, just this, it says for each key in my dictionary, I'm going to name each key building, and then I'm just going to print out the key. So this is a loop, and it's just going to go through each key value pair and print out just the keys. If I wanted to print out the values, then I add this other part. This prints out the values. Okay. Any questions about what it's doing there?
I guess I'm not catching that it knows the building, in the for building in my dictionary. I'm trying to find where it tells it the building is Kelly Walker Johnson Lucas.
Okay.
It knows
Right.
what to put down.
I could call that's just the name of a variable. So other computer programming languages might make you explicitly define that. They would say, like C, I'm pretty sure you'd say for key equals the name of, I don't know, something. But Python, what you do here is say, you say for, and you give it the name of a new variable that you're going to use just for this loop. And that loop is all of the keys. Okay. This is covered pretty well in the book too. So if you're not liking my explanation, go look at the dictionaries section of the book where. So what it's basically what you read. The way you read this is for keys in my dictionary, and the name that you give the key doesn't matter. It's helpful sometimes to name it what they actually are. In our case, they're buildings, so I wrote BLDG. BLDG. I only called them that because they represented buildings to me. But that's the name of the variable. In fact, I could have called my dictionary BLDGS, buildings, and put that down here. So this is saying for building, because really all this is a set of records, building records. And so I'm saying for each building record in buildings, but it's not returning the whole record, it's only returning what? What is building each time? The key. Yes. And so to get the value, I actually have to, I have to change this back too. Okay. So now I'm saying, go back to all of the buildings and pull out just this building because that's what it's going to be this time. I run this, now it'll run exactly the same way. So what I could do, I'm gonna take, whoops. I'm gonna comment these out, or sorry, uncomment these out. I'm gonna leave that there, okay? All right, so what if I take this and put it here? Now, what's going to happen is every time through the loop, it's going to print the building, and then it's going to print a comma, and then it's going to print the number of stories, which is the value in the value in the dictionary, and then it's going to print a new line. Okay, so I'm going to run this guy. Oh, I need to put a plus sign there to concatenate. And then I still have it open. So that's the problem. You can write over everything except for something that's open. It won't let you do that. So that could be something that saves you if you need it. Okay, where'd it go? Right there. Run. Oh, what does this mean? Cannot concatenate string and int objects. How could I fix that? Where's an integer object here? So I'm adding building, and I'm adding a comma, and I'm adding buildings. What does this evaluate to? First time through the loop. First of all, what does building, BLDG, evaluate to? We ran it already. What did it equal the first time? Exactly. It's the key. It's the key for the first item in the dictionary. Okay. So what data type is this? String. Okay. We can add a string to a string, right? We know that. What data type does this evaluate to, or what is it? And then what data type does it evaluate? Right. So what's happening is this is an integer, and we can't add an integer to a string. We get an error. And so we have to do that string conversion function, str, and that'll turn it into a string. Now, finally, if we run this, we won't get any errors. And we should be able to open it. And now we have a comma delimited, a CSV, comma delimited text file where we have a header, building stories, and we have a list of buildings and the number of stories a building has. Okay. Let me open this back up to where we were. Okay. So this creates the dictionary. What does this line do? Tells me where to put what?
Output.
Which is, what is the output going to be in this case? A CSV file, right? It's just a simple text file. So it basically creates it on disk at that point. In fact, if you were running this and you could look at the data structure, at that time, all of a sudden, in Windows Explorer, you could see output.csv, right as this line ran, okay? However, it would be empty. It would say 0 kilobytes next to it. So the next thing is that it writes, what does it write here? What's the purpose of this line? It's writing something to the file, but what is it writing? It's just a header. I'm adding a header for the benefit of whoever's going to end up using this file. Okay. All right. Now, this is the part that I think that we'll struggle the most with. This is a for loop. And again, you read this, for every key in buildings, and we're naming the keys BLDG. And so the first time through the loop, BLDG is going to equal Kelly, then Walker, then Johnson, then Lucas. And again, the order isn't predictable. It may be Lucas, Johnson, Walker, Kelly, or it may be Walker, Johnson, Kelly, Lucas. The point is it'll go through every single key in the dictionary. It'll go through every single key in the dictionary. It may go through in a different order, but most of the time the order doesn't matter. We just wanted to make sure it goes through every single one. And then it will write the name, the key, in this case, name of the building. It'll write a comma, and then it will write the value, which is in this case this value, this value, this value, that value, and then finally it'll put a character return, and then we need to close it. If you do not close it, it will actually continue to be a 0 kilobyte file with nothing in it. So when you're writing text files in Python, you have to make sure you close them. You can get away with not closing a file that you read, but it's best practice is to also close the files that you read. All right, the last thing before we take our break, let's take a break, is did all of this. I did not cover the format operator. That's what I want to talk about. And we may save this reading directories. In fact, we are going to save that until next week. So remind me that we're still going to cover directories and this try statement. We're gonna cover all that next week. All right. So, but we are going to cover this format operator today. Oftentimes, when I'm writing programs, I write them similar to the way I've written this statement here. But in some ways, you could view this as being a little bit archaic. Okay, so there is a better way to do this in Python. Python will use the percent. Remember what the percent was for numbers? The mod operator? Well, the percent operator also works on the percent operator also works on strings, and that will basically allow you to format. Trying to find good examples of this. The book has a lot more great examples of that. We should just do this after the break, but you can do something like this where you say, okay, yeah. Actually, let's cover that after the break as well. But what I'm going to do here is say, instead of writing this, you could write it something like this. I just want to make sure I get the syntax absolutely right. You could write something like this. I'm pretty sure it's like this, and then like this. Let's do this right. I'll have to open. And this is mostly about finesse. I'm not getting the syntax exactly right. So although this runs, there is a way to make it so you don't have to do so many string concatenations. And I should have looked that up before class. In practice, I normally do this first one, but I wanted to show you that this is available. I just have to figure out the correct syntax for doing it. All right, so we'll do that. We'll take about a 15-minute break, so we'll come back about 5 minutes after, sorry, that's 35 minutes after the hour, and I'll figure that out and get a drink. Any questions about what we talked about so far? All right, cool. And then we've already done one of the things I wanted to talk about in the lab, and we'll demonstrate a few of the things for the lab when we come back. Making sure this is still recording. This week I'll probably restart, because I've had a couple of the lectures stop. In this class, I don't know if they've gone all the way through, but in my other class, I've had a couple of them stop. So I'll probably restart a new broadcast when we come back. I'll be right back. Just give me a drink and get that syntax exactly right. And maybe I should leave up this one. All right. I'll see you all in about 15 minutes. I don't know if this is for sure, but the reason why I was asking about where you go, I was wondering, I have a colleague coming with me, and he's leaving out of the airport at 4 o'clock next week. So I was thinking about just saying, hey, you can drive my car to the airport. And then if he does that, what I can do is you can take me maybe, if you're agreeable. You know how the airport is, like, the thing is just right off. They just drop me off, I pick my car up, and continue on.
Sure.
Probably next, probably, I may find it, my wife may be able to take it, but if not, then.
Okay. Yeah, that's cool. Yeah. That's why I don't understand how we can, I got on the X and the Y, right, in the two, but this, there's no reference to that.
I like how we did the building with the buildings. You know, do that with whatever, right?
Yeah, that's why I shot it on my phone too.
Maybe just write down the minute on it.
Oh, yeah. I did a podcast a bunch, like, what's the podcast? Yeah, 1.5 times is usually the best for something, because you get a lot less of it. Okay. It's what was most of that, say, okay, just what you said, hold on. I'll watch Carolyn to take care of. Yes. I'm using them in mine. Just wanted to this really here, so you can watch the colors. Watch the colors. Yeah, I'll try to give you one. You know what's in the ball, and you don't need to Years without anything there is to offer except for video and relaxing. I have to take a lot of GIS. Yeah, I have to take a lot of GIS. Let's see. I have this very cool. I thought I was in the project, which was just GIS. No, sure. It was vector, yeah, it was vector. Yeah, I was the technical class. I think it's a master's student back in 2004, but after like there's like an 8-year scheme with the literature. Just going over count for the group. But that was, I got my PhD, but oh yeah. Yeah, it's kind of good. You go to see a friend, you catch a ball game, and on the I froze. We got a ball. What?
You want a real one?
But no, a long shirt, like a long sleeve shirt. Get a ball game. I went to, I saw we went to AAG last time, in San Francisco, we called a Giants game, playing Diamondbacks. And we were at the game, I'm thinking, it's April, nothing to worry about, it's like our first night there. But we go to the game, and all that stuff. Hold on, please. We're in California, it's April, it'll be fine. No, it was a cool, damp, like 5.
Yeah, I'll let you see it.
What you should have worn,
Oh my God, I'm sorry.
I have been to like 5 or 6 movie parks. I want to go to all of them. I haven't really traveled most of my own still there. Next year, planning for in my life in the Heights, where Seattle and Portland for sightseeing. That's all we're going to do. Sightseeing. Making plans, hopefully see the Mariners play. All right there. I also and to first one. I might hit both. I might hit Vancouver, Washington too. The plan is Vancouver, Seattle, Portland.
Oh yeah, I'm going to this summer. We're going to go. Maybe I already mentioned this, but we're going to go to Portland.
I'm going to next summer for our 2-year anniversary.
Nice. We're going to pack all the kids up in the van and drive.
Oh my gosh, no, that's too far to drive with kids.
We'll actually have 3 drivers.
Oh.
My oldest turns 16 next month.
That's right. You tell them, like, all right, you're going to drive all the way across Texas. Go.
Yeah, I don't know exactly what we do that Texas drive a lot, so we may try to go on more of a yeah.
I-70 kind of deal.
Yeah, who knows?
Yeah.
All right, I only left one thing out of my my syntax there. So this is the syntax. So basically, what you could do is to write an entire thing. Like you could make it as long as you wanted to, and anywhere where you want to have a variable substitute in, you put a %s. So I'm saying %s, comma, %s. So in other words, I want the first thing to be here, the second thing to be here, and then I want a new line character. And then you have to have another %. It's an operator instead of a plus operator. It's a % operator, and then what you need is basically a tuple that has you have a tuple that has the same number of %s's that appear over here. You have a tuple of the same length over here. So this BLDG will go into the first one, and the BLDGS, whatever this value evaluates as, will go in the second one. And there's no need to do any type conversion. So it'll do that for you. So now if I run this, it'll look exactly the same as the other one. If I open it up, oops, it looks exactly the same. So it's some people view it as a more elegant way to write it. So you can put your things here. So for example, I could have written something like this: building, colon. Now if I write that again, run it, open this up one more time. So now I'll put that word building colon. I mean, not that you'd ever do that, but that's an example of using the format operator. So I want to do. I want to close this. Don't save. And I wanted to remove this out of there. So there are, you can explore that format operator quite a bit. There are ways of, like for example, if one of these values represented a float, you could actually format it and tell it to only put 2 decimal places after the float, or 3 decimal places. So there's all sorts of things, but those are getting, there's not really anything geographic. There's not really a reason. That's more about making a pretty report and less about making Python work. So we're not going to cover that any further. But like, let's say you wanted to generate a report that only had 2 decimal places, and you can come talk to me. Or if you wanted to do something else, you wanted to have a certain amount of leading spaces or something. Did you have a question?
No, I got it to work. I got it to actually save the desktop finally.
Okay, great. Yeah, I don't know if it's the same on the coast, but sometimes there's a few places on these computers you can't write to. Some places you can write to. I do think the desktop is one of the places you're allowed to write to, but I think most of the C drive you can't write to. So I don't know if you're having the same kind of issues on the coast. But anyway, so that's that. Oh, I said I was going to start a new tape for the lab. Let's make sure this is still recording. So I'm going to go ahead and do that.